All right, class, this is example 2 on page 440. All right, so you can read through the problem. What they want to find this time is if there's a difference between the two. Is there a difference between what we did last year and what we did this year? Okay, so we're just trying to determine if the mean, if there's a difference. So mean of the differences, it's either going to equal 0 or it's not going to equal 0, right? This is that same thing. D equals before minus after. In this case, we don't care which one's bigger. We're just trying to test the claim that there is a difference. Okay, so this is going to be a two-tailed test. So we're going to use inverse t to find our critical values, if you want to go that route. Okay, so the critical values would be inverse t, number 4. All right, so here's what I got in there, y. Okay, so we're trying to determine these two critical values, all right? And our alpha value is 0.01. So that 0.01 is divided between here and here, okay? So I want to find the number here and the number here. And then these would be our rejection regions out in these areas. So what I want to do, I'm just going to look for this one, and I know that this one is just going to be the positive of it. This should give me, this side here, should give me a negative value. This side should give me a positive value. So I'm going to take 0.5 of 0.01, like I have on the calculator. Degrees of freedom, there's 16 pieces of data, so our degrees of freedom is 15. Hit enter. Okay, so if you use the critical value route, this value is negative 2.95. This value is positive 2.95. So we're going to run a t-test and determine where our d is. Is it in here? Is it out here? Or is it out here? If it's in here, we're not going to reject. If it's on the two sides, here or here, we will reject. So again, you got to do a little setup on your calculator for this. You got to put in all these pieces of data. That's going to take the longest time for these problems. So pause the video if you haven't done so. If you haven't put these values in, I have the values in. What we want to do is take L1 minus L2 again for column number 3. Hit enter, and it fills in all the data for us. Okay, so now we want to do an inverse t on L3. So, or not inverse t, we want to do a t-test on L3. So go to test, t-test. All right, it should be all set up from the last time. The only thing I need to change is that, because now our HA is not equal to. Calculate. All right, so we get a t-value of 1.37. It's not in the rejection region. Okay, we can also use our p-value of 0.1911. Is that less than or equal to our alpha value of 0.01? Alpha value of 0.01. Nope, this is not less than this, so we fail to reject in both cases. Okay, and our claim is with HA, so we can look back at page 356, and this time I have 356 here. All right, there it is right there. This is page 356, that little chart. This comes in handy for all these problems. Our claim is HA, and we fail to reject, so we just write down what it says there. There is not enough evidence to support the claim. That there's a difference. There's not enough evidence to support the claim at the 1% level that the legislator's performance rating has changed. And this is kind of an interesting. What level would I have to get to in order for this to change? It looks like I'd have to get to a level of 2%, right? No, hold on, that would be 20%. If we got to a level of 20%, then we could reject and support the claim. We could reject HO and support the claim. But remember, the higher this number, the more chances you're going to get a false positive or a type 1 type 1 error. And we don't like type 1 errors. Right? Okay, so hope this helps.